In this video, we will see one example how this unsigned binary multiplication algorithm can be used to multiply two numbers. So the same example I am taking multiplicand with multiplier. As per the algorithm, we will be using certain registers which are C, A, Q and M. So your M is going to contain the value of multiplicand and Q will basically initially it will contain the value of multiplier and A will have a value 0 initially and carry is a 1-bit register will contain a 0 initially. So initially these two registers will contain 0. Let's assume we are using 4-bit adder. So all the registers are of 4-bit and this is a 1-bit register. Okay, Q is the multiplier. The multiplier here is 1, 1, 0, 1. Multiplicand here is 1, 0, 1, 1. So this is the multiplicand and this is the multiplier. Okay. Okay, so multiplier is here. So let's try to see. This is the initialization. So initial values are given here. This is the initialization. Okay. Now let's try to have the iteration. So I told you these two tasks, checking, adding, shifting. This will be done few times. Here the few time is 4 times because we are using 4-bit adder. Okay. So let's now check Q0. Is it equal to 1? What do you mean by Q0 is 0 means 0th position. This is your Q. This is the bit in 0th position. You just check that bit. Is it equal to 1? Then you will add something and then shift. If it is 0, you just shift. No addition. Okay. So the Q0, the 0th position. The 0th position. Is it 1? Then you add A with M and put the result in A. If you have a carry, put it in the carry bit also. Okay. So here in our example, of course, the Q0 is 1. The condition is true. When the condition is true, yeah, you need to add. What you need to add? Okay. C, A you equal to A plus M. So what is the bit in your A plus M? So okay, here is it. A plus M. Okay. So what is A? In this example, A is 0, 0, 0, 0 and M is 1, 0, 1, 1. When you add them, you will get the M again. So put it in this A. When you have a carry, put the carry bit in this register C. Okay, here I don't have a carry. So fine. So the answer in the first iteration, this is I'm doing the first iteration. The answer of this addition, I'll put it in 1 0 1 1. I don't have a carry, so it's 0. Q as it is, you write it as it is. M as it is, you don't change M. Okay. After you finish adding, according to the algorithm, you have to shift. What are you going to shift? These 3 registers will be shifted. C, A, Q. So those registers will be shifted to the right. Okay. To the right is to this direction. Okay. To the right direction. Okay. To the right side. So these 3 register content will be shifted to the right. We already saw the shifting. When you shift something to the right side, so the right side bit, the least significant bit will be gone. You will have a 0 in the most significant bit. We already saw in MIPS. Few examples. Okay. So the same concept you are going to do. So this C, A, Q will be shifted to the right side. So you will be losing this bit. You have additional 0 here. Okay. So you will have additional 0. This 0 comes here. This one and this 0 and this one. And this one goes here. This one comes and this one comes and this 0 comes and this 0 is gone. M as it is. You don't change the value of M. So this is your first iteration over. Now I am doing the second iteration. Again I will check the Q0. That is the algorithm. Check the Q0. This is the 0th bit. 0th position of Q. It's now 0. When it is 0, don't do any addition, just shift. What are you going to shift? Again the same thing. C, A, Q. So what is the value of C? What is the value of A? What is the value of Q? All those bits shift to the right one bit. So you will have a 0 and this 0 comes here and the 0, 1 and this 0. This one goes here and this 1, another 1 and another 1. So this 0 is gone. One bit will be lost. Write the M as it is. You don't change the M. So your second iteration is over. Now I am going for the third iteration. I told you we will be doing it for 4 times because we are using a 4-bit adder. Okay. Condition again. Check the Q0. Is it equal to 1? Q0 means I told you already 0th position of your Q. Now it is 1. If it is 1, add A and M. Okay. So let's try to add the A and M. A is, so I'm going to do the A plus M. Your A is 0, 0, 1, 0. Your M is as it is 1, 0, 1, 1. So when you add, you get here you get a carry and here no carry. So again I don't have any carry here. Write it as it is. Okay. So no carry for this addition. The answer is 1, 1, 0, 1 and this one as it is, don't change, and this one as it is, don't change. Now I added. According to the algorithm, add, shift. What is the shifting? C, A, Q. Shift to the right. You have a new 0. This 0 comes here. This 1 comes here. This 1 comes here and this 0. And again this 1, another 1, another 1, another 1. And this 1 is gone. The least significant one bit will be gone. M as it is. So I finished with the third iteration. Let's go to the fourth iteration. In fourth iteration, again I am checking. According to the algorithm, check. Is it Q0 is equal to 1? Of course. The Q0 is 1. Now you need to add A and M. Okay, let's do the addition. Your A is 0. Here it is A. 0, 1, 1, 0. M is 1, 0, 1, 1. When you add 1 and 1, you get a 0, you have a carry. 1 and 1, you get a 0, you have a carry. Again 1 and 1, you get a 0, you have a carry. So this is your carry bit. You got a carry now. So write it. So carry is 1. The A is 0, 0, 0, 1. And the Q is, write it as it is, and the M is, write it as it is. Now according to the algorithm, shift it. So shift the C value, A value, Q value to the right side. So you get a 0 and this one comes here, this 0 and this 0 and this 0 and this one goes here. Okay, and this one comes here and this one and this one. Okay, this one is gone. And M is as it is 1, 0, 1, 1. So your fourth iteration is over. So you finished with your algorithm. Now let's see what is your product. The product is in the registers. Okay, whatever register C, A, Q contains is the answer. So what is my register C, A, Q contains? It's here. C is here. This one. A is here and this is the Q. Okay. So C contains a 0. A contains 1, 0, 0, 0 and the Q contains 1, 1, 1, 1. So this is the answer product. Answer of the question. So this is the algorithm for unsigned binary multiplication.